Let me check the tutorial version here. If I've already uploaded the latest tutorial question. Okay, I will upload the version 2 now, the tutorials and notes. Yeah, but is this sufficient to cover tutorial today lesson? Okay. All right, let's go back to our lecture. Now, previously we'll stop at this moving average. Huh? We are now doing, we're now in chapter 4. We are doing forecasting. Huh? So we have looked at one of the method under time series method. We do moving average. Moving average given by this formula, moving average MA sub n means number of sample, and the total demand divided by the numbers of periods that you choose. Yeah? So we have seen example 1 by using this simple data, and we have shown you how to do moving average for 3 months and 5 months. We did all this exercise in a previous lecture. Okay. Okay, so we have done moving 3 months and then 5 months. So I ask you to go home and do some revision about the numbers in the blank here. Okay. I even give you the reference answer for the things. And we have also discussed about the chart. Blue is the raw data, and the red line and the sky blue line, this one, is 3 months and 5 months moving average. And each one of that have their own benefit or their own advantages and disadvantages. Okay. Today we learn one more new things. It's called weighted moving average. Okay, weighted moving average. Previous lecture we stood at moving average. Now today we learn something new. It's called weighted moving average sub n equal to sum of your weight value and total and demand. Wi di means, if you look at this mathematics model, means you multiply your weighted your constant value and the demand, then you add all the number together. Okay, then you are doing the moving average. Okay, moving average. So moving average, weighted moving average is also another method we do forecastings. Right? So previous lecture we stopped at moving average. Today we learn something new called weighted moving average with a constant value on the demand. Okay, so just copy this equation, and the definition of weighted moving average means weight are assigned, means a constant value was assigned to the demand, and so that you can manipulate a little bit for forecasting data. All right, and sum of Wi. Sum of Wi means if you add all the constant value together, you will get 1. Okay, you'll get 1. Weighted means you add a constant value, a percentage of value, right? And maximum numbers, or you add all the numbers or constant value that add into the data is 1. Later you'll see what does it mean. So currently you just copy this formula. Then we'll apply this formula in example that I'll show you. Okay. So if the most recent periods are weighted too heavily, the focus will be overreact. It might overreact to the random fluctuation. So you need to be careful on the weighted constant value that you use. And normally when it comes to this section, in the exam or final exam, or even in your assignment later, this weighted value, most of the time we will give you. And because this weighted value, it need experience to build and to adjust accordingly. So one of the effect, if you input too heavy constant value inside your forecast, it will overreact. Means sometimes you project too extreme data. Too high, it can be either too high or too low. Right? And we have seen what happened when you over forecast or under forecast to the supply chain, right? So it is not a good thing if you overweighted your data. Okay, same opposite. Either error done by the forecaster, either they are over heavy weighted or too light, means not enough constant value that apply to the data. Okay, so this actually the same meaning, only the opposite effect. Now this one is it used, right? It's used what you call okay, this is just to tell you that it is not easy to determine the constant value here. Okay, later we will look at example, then all of this will make sense. Currently, because we are new to this formula, so you won't see what is all this mean. Let's look at example 2. Example 2. So this company that we done in example 1, right? So again, recap what is example 1 company do. So a company in example 1 is forecasting some orders from January to October. Okay, this is the real data they have, January to October, the order they have. Then when you come to example 2, so now the manager or the owner of the company, you want to compute a 3 months weighted moving average with a weight of 50%. Meaning now the value or the constant value that you use in the forecasting is 50% from your raw data. For October data, and here is very specific, 50% for October data, a weight of 33% for September data, and weight of 17% for October data. What does it mean? It means there are some adjustable quantity to the October data, 50% October, September 33%, August 17%. This weighted reflect the company desire to have the most recent data influence the forecast very strongly. Okay, now the company give you some info. Now you do forecasting based on the constant value given for October, September, and August. This is the formula given. So weighted moving average equal to the sum of weighted times demand of individual weighted and demand. So by having this formula, you can expand this mathematical model based on this statement. How many months was mentioned here? 3 months, right? 3 months, you have October, September, and August. So you have demand for October, September, and August. What about this one? This is the number given by your customer or by your manager. This is the weighted constant value. 50% of October, so you have 50% here, 0.5 to October data plus weighted of 33% of September, 33% multiplied by September data plus 17%, 17% here. So you have to change percentage to decimal place. Okay, but 70% August demand. You add all together, you get a weighted moving average of that month. Okay, so recall this table from example 1 in your tutorial handouts. You have this demand, okay, January to August. And now your manager asks you to calculate forecasting based on weighted moving average and 50% for October, 50% October, 33% for September, 17% for August. So you use this table to calculate. Okay. So we are doing weighted moving average for 3 months. N means the 3 months period. Right? Compile a 3 months weighted moving average. So your N is 3. So you're focusing on these 3 months. This is how you calculate by mathematical models. What is the October demand? 90. What is the weighted constant asked by your manager? 50%, 0.5. 100% is 1. 50% is 0.5. Do the same for the another month. September, 33% was given in the statement here. So September 110 order times 0.33. You do the same for August. August 17% multiplied by 130. You add all the numbers together, you get 103.4 orders. This is how you do weighted moving average for 3 months. So if 5 months, then the manager have to give you the weighted percentage for another 2 months. So this is 3 months. Any question for moving weighted moving average? It's quite direct here. Okay, good. Sarini, you okay? Sarini, are you there?
Yes, sir.
Yes, sir. Are you all right? Have any question?
Yes, I'm okay.
All right.
Yeah, yeah.
Okay. Okay. So just a note, when you do forecasting, okay, always include the decimals behind your numbers. Raw data is okay, you don't have decimal place, but when you do forecastings, minimum 1 decimal place behind the full number. Okay. When you do analysis, always have 1 decimal place. And one reminder here is that when you complete your calculation at your final answer, when you need to give a answer to your manager, which is your manager expecting 1 full value, so you need to give your manager round up to the nearest one. Okay, or then move up or move down to the round 1 full number. Okay. So as you can see, this is the weathered moving average for 3 months with the percentage given 50%, 33%, and 17%. You compare to the previous one that you did for moving average. Your moving average for 3 months is 110 orders for November. However, after you did analysis using the weighted constant value, it reduced to 103.4 orders. Okay, so it's tell you that this is that when you use weighted, it get very near, much nearer to your most recent data. For example, you're estimating October. You see the differences. If you use the moving average, you get 110, which is here. 110 forecasting in forecast for November. But if you use the weighted, it reduces the numbers to 103.4. Means you're forecasting the numbers a little bit nearer to October compared to 110. 103 is more nearer to 90. Okay, this is the effect after you do different approach. One is moving average, one is weighted moving average. Okay, we have done with two methods, moving average and weighted moving average. Now we look at another methods. Yeah, another method is called exponential smoothing. Later you will see a lots of equation, but don't worry. Exponential means you in your mathematics you learn three types of equation: polynomial, quadratic, and also linear, right? So linear, quadratic, and polynomial. So exponential is one of the. It can be either quadratic equation or exponential equation. So let's start with the definition. Exponential smoothing. We use an average method that reacts strongly to recent changes in the demand. So exponential smoothing is one of the method we respond to the latest changes in the demand. Okay, given so the advantages of using exponential smoothing is they are specifically good for those data that is unpredictable. Okay. And one of the benefit when you learn the exponential smoothing later, it requires minimum data compared to the previous two methods that you learned. Weighted average and moving average. This one need lower data, lower number of data. So, and exponential smoothing, nowadays if you use computer software to do forecasting, this is one of the default function inside the software itself. Okay. Okay. This is the equation that we use for exponential smoothing. Look at the pattern. All right. Look at the pattern. Don't get scared by the exponential format of the equation. So you have f sub t plus 1 alpha dt plus 1 minus alpha bracket ft. Now in mathematics, you know that if you look at that particular time, now, the time now, we use t means ft. Okay, ft. If you use t, means present, the now data. F sub t plus 1, what does it mean in mathematics? It means the next forecast number. Ft plus 1 means next number. For example, if now you're in December. So the data that you have, you forecast for data, right? Let's say you forecast for December. Your numbers will fall under F sub T and demand at December, DT. You know that you can do, this is demand. Demand is the raw data. You cannot do anything. You just copy and use. So DT is a current month or the month that you're calculating. Okay, let's say December, DT, demand at that particular month. Let's say DT is you're calculating December. So you can do forecasting for December. So FT means forecasting for December, this month. Forecasting, you can use demand of this month, forecast of this month, to project forecasting for January 2022, FT1. Okay, by looking at this mathematical model, it means that you need to use current data, current demand, plus the forecast of this month, combine forecast plus demand, you get the forecast for next month. Okay, this is the general idea of what the exponential smoothing is doing. The rest is just what I mentioned just now. Alpha is a constant. So smoothing constant is a constant value that you put in, like the weighted constant just now. But now we use alpha because why? Because we are now looking at different mathematics model, but it behaves similar like weighted constant just now. But now we use alpha. Okay, alpha appeared in exponential smoothing formula. And again, the smoothing constant here is from 0 to 1. If you want to smooth your data, become flat line, what you do, you input alpha 1. The back one gone. 1 minus 1, you get 0. So you don't have forecast for current month. And 1 means alpha 1 means you use 100% smoothing constant. 1 dt means current month. Straight away, current month will be carried forward to next month forecast. Can you see the effect if you change the constant? Okay, smoothing constant is from 0 to 1. 1 means 100%. If you use the 100% smoothing constant, this component will be gone, will be 0. This one will be 1. So the current demand is the focus for next month if you use smoothing 100%. Okay, let's look at how we apply this formula for a real data. This is just another example. Okay, if the alpha given is 20% or 0.2, the formula will become 0.2 dt plus 0.8 ft. Meaning, what does it mean? To forecast for next month using smoothing constant of 0.2 or 20%. How you get next month forecast or next forecast? You use 20% of current demand plus 80% of your forecast, current month forecast data. You combine together, it will become your next month forecast. Okay? This is the concept of exponential smoothing. It needs two data, demand data and forecast data. Okay? Let's look at one example so that you can appreciate the equation. Yeah, this one I say just now. Let's look at one example. This example also available in your handouts tutorial. I think version 1 still have. If not, then you go and download the version 2 that I just uploaded in the Teams just now. So basically, example number 3 is we're going to use the exponential smoothing forecast. So we have a company doing computer service for repair and services. Then they say that you use part-time student as their workers and their technician. So the company have steady growth, so meaning they have a very good business. It purchased generic computer parts in volume at a discount rate from their supplier or from their vendor whenever they see a good deal. So they need a very good forecast for the demands for repair so that they can take the opportunity to purchase the parts when they do servicing in the lower rate. So when they buy low, sell high, they make high profit. Okay. Yeah, so they just want to use the exponential smoothing forecast so that they can know how many parts they need to buy. Okay, so a few components they need to know. They need to know how many computer components to purchase, how many to keep, and how many technicians to hire in the future. Okay, so you're having a raw diagram here or raw data here. So this company actually keep the HR department and the stock, the planner in the company. They have a data that you see on this table. This table gives you from January to December, and the demand is from 37, fluctuate, 37, 40, and so on for each month. And the company or your customer want you to give them a forecast. Consider exponential smoothing forecast using smoothing constant alpha equal to 0.3 and 0.5. So basically the customer want you to run two scenario forecasts. One is use alpha equal to 0.3. Another case, after you run the scenario for 0.3, you run for alpha equal to 0.5. Okay. So for exponential smoothing forecast, you only concern about alpha, which is the smoothing constant. Okay. So this one you should have in your tutorial already. So let's convert this data into a workable template or table form. So I move my data over here, which is I just put as a side reference here. Okay, as a side reference here, and I believe you already have the tutorials in front of you. So this is just a reference for me to guide you through how to do calculation. And I copy also the alpha value the customers ask us to calculate. We have two scenarios to run, alpha 0.3, alpha 0.5. You need a table like this. And I believe in your tutorial handout also I give you this table, if not mistaken, because I prepared the tutorial quite long ago. So, so you should have this table just to help you to follow the lecture a bit faster. So you copy, in the exam, you're only seeing this raw diagram. So in exam, we expect you to build this table, or in your coming assignment, we'll expect you to build this table. So period 1, 2, 3, 4 until 13. So basically your raw data is until 12. You need to estimate what will be the incoming forecast for January. Because the customer already give you from January to December, the customer want to know what happened in next year January. So there's a 13 period there, 1 to 13 January. Then this is your working space here. You're going to do forecast ft plus 1. So all these values are your ft plus 1 data. Okay, inside this table, all these are your ft plus 1. Alpha 0.3 this column, alpha 0.5 this column. So you work on 0.3 first, then you complete this one. They are total of 24 calculation here. Each month have their own calculation. You have 12 set to go. You have 12 set of calculation to go. So 12 plus 12, you have 24 calculation here. But I will show you how to do the first one. Example, if you copy this raw data into the table form like this, you need to forecast January. So for the first month, okay, again, for the first month, January, because you want to generate F plus T for January, there's no data for you to calculate. It's the first month for the forecast. So you don't have data for that. So that's why there's a no data symbol here. Okay. So for exponential smooth forecast, usually the first month is no data. Next, we copy the equation, the smoothing forecast F plus F sub T plus 1, which is this column, equal to alpha dt, which is the current month, plus 1 minus alpha. This is the smoothing constant. You have two smoothing constant. We focus on 0.3 first. So this is 0.3. Okay. January also don't have demand because in the raw data you don't have. They want you to forecast, do forecasting for January. So there's no real data for January. Let's do calculation for the green color box here. We just calculate F plus T for February. How do you calculate based on this calculation? Okay. Okay, so to start February, we will use demand for period 1. Okay, this is period 1. Okay, this is period 1. We use demand for period 1 as both demand and forecast for period 1. Okay, so this is a statement to start calculating for the green box there. So this space here, is forecast number 2. Okay, yeah? This space here, this number is F number 2. Okay, this space here is forecast number 2. So I write F2 equal to alpha D1 plus 1 minus alpha F1. Before we move forward, compare two mathematics equation here. How you get 2? You get 2 when your t equal 1. Correct? Ft plus 1, you get 2. So your t value is 1. So your alpha copy, D, you already get your t value from the previous one. T value is 1. Ft also, t is 1. So you copy. Once you derive the equation, you calculate the second forecast. F2 equal to alpha D1 plus 1 minus alpha F1. First, you have to understand how to modify this equation into the useful one for the data. We are now calculating for February, the green box data, which is give you the focus number 2. Okay, focus number 2, you need to use data demand of period number 1 and focus for number 1. Okay, so in this case, we will use demand for the first one to kickstart our calculation. We will use 37 as our demand and forecast for the first month, because first month we don't have any forecast. So in this case, demand D1, you know from table, is 37. D1, this is D1, right? D1, D2, D3, D4, and so on. So D1 is 37. But for forecasting for F1, we don't have. So how to start? We use F1 equal to demand 1 to kickstart. But this one step only apply for the first step. The rest later you use the same concept and apply to the previous one. We substitute the value. F2, focus number 2 of this green box here, equal to 0.3, y 0.3, this is alpha 0.3. The customer asks us to do 2 set calculation, 0.3 and 0.5. So 0.3 alpha, D use 37, 1 minus alpha, your alpha is 0.3, you get 0.7. Focus 1, we use 37. This is for the first set. You press your calculator, you get F2 equal to 37 service call. Because this company, they want to know what is the demand, or what is the expected customer demand. So here you calculated 37 service call is expected for February. You write 37.00 in this column. Okay, I give you 10 seconds to look at the slides. See if you understand or not. How you get 37 service call. Okay. Again, if you don't understand, ask me. This also one of the, I call it as a dangerous question. Why? Because the numbers will be snowballing. If you're not careful, the first one you did wrong calculation already, the rest were wrong already, sure wrong, because it will snowball the numbers using same equation. You fit the previous number into the next one. Yeah, go ahead. What question?
Sir.
Go ahead.
So why we are not using the 0.5?
Where is 0.5?
For the alpha value.
Okay. So what alpha we are calculating now? The green box, they are fall under alpha or alpha 0.3 or 0.5. You are doing you have 2 columns to calculate. One column is 0.3, one column is 0.5. This calculation is doing the green box area. Okay, all right. So I will answer your question later. I have one example for 0.5. We are now focusing on 0.3. Okay. I will do the second calculation for you. What happened to March forecast here? All right, using the same equation, smoothing ft plus 1 equal to alpha dt plus 1 minus alpha ft. Ask yourself, when it comes to March number 3, you are focusing this one. What is the number that you should write here? F what? You should write F3 because it's number 3. It is number 3 here. So F3. So when it become F3, your T is number 2. Right? F3, this is F3, right? This column, this box here is F3. So this is the general equation. So F3, T plus 1. So your T is 2. So alpha D2 plus 1 minus alpha F2. Okay. You modify the general equation, become this one. F3 equal to alpha D2 plus L1 minus alpha F2. You should understand why T is 2 now. You calculate from the first one because this is F3. How you know is T is 2? 3 equal to T plus 1, T is 2. So by looking at this formula, you're calculating this box. Alpha still 0.3. 1 minus alpha 0.7. What is demand number 2? Where's demand number 2? This one.
40, sir.
D2, 40. What is forecast number 2? This one.
37.
Yes, correct. You put in all the value, press calculator, you get 37.9 service call. You put this number inside here. All right. So that's why when I mentioned when you calculate for this exponential smooth forecast, always double check your answer correct or not. Do you press? Important is the first two. The first two number correct, the rest should be correct. Although there are some minor, it's very rare. If it's very rare, you have mistakes after this. If the first one wrong, second one sure wrong already because you are recycling your F2. You're recycling this number. If you press calculator, you write 35.00, this number wrong. F3 wrong, this also wrong. So basically I don't need to mark already. The following will be wrong. If the first two number wrong, the rest will be wrong. Marks for table, usually if I have 13 or more than 10 data here, normally the table will cost you 5 marks. Sometimes I'm very generous, I give up to 10 marks for table. So if you calculate wrong or careless mistakes for the first two, you might lose minimum 5 marks to 10 marks. And basically you lose the whole question actually. Right? So we have done for, I've shown you the second data already. You should be able to do the fourth one, right? Okay, let's do one more example. Same equation. Now we focus on number 4. It's April, so you should do the same, right? So maybe I give you 20 seconds or 30 seconds. Calculate the forecast here, forecast number 4. What is the value that you get? Okay. Harry Sayam, are you there? Is it Harry Sayam? Not Harry Sayam. Nevin, are you there? Calling for Nevin. Calling for Nevin. Calling for Nevin. Let me text Nevin. Again, this is a recorded video. If I call you and you do not respond, mean you're not in the class. You consider absent. Okay, text has been sent to Nevin. If Nevin do not respond in 1 minute, Nevin, you consider absent from my class. Okay, next one, I'm going to ask Guru Darshan, are you there?
Yes, sir.
Guru Darshan, what is the answer for this bracket here?
38.83.
38.83. Okay. Seems like correct answer. Let's check. So, okay. So you have F4 alpha D3 plus 1 minus alpha F3. Press the calculator, right? 0.3, 41, 39.9, 37.9, 38.83. This is correct. Okay, good job. All right, so if you understand the concept from here, you should be able to do from May until December. Okay, important step is the first one. We reverse the concept a little bit. How you get 37 for the first one, F2. Okay, F2. Okay, your F2, your T is 1, demand 1, forecast 1. To calculate 37, you don't have forecast 1. You don't have, because the first month is the first starting month. You don't have forecast. What you do, you use demand as your forecast 1. This is the only reminder that I can give you. Okay, for F2, you use F1 you use demand, first month demand as your forecast 1. Okay, that is the only careless mistake that I'm concerned. Because sometimes you cannot start, you don't know how to start, then the rest you don't know how to do it. Because the rest is just snowball from the previous one. You recycle the previous numbers here. Here normally don't have mistakes because alpha multiplied by demand. Demand you copy from the question, so normally don't have careless mistakes. Only here, the second part of the equation. This is the careless mistake source. You don't know how to use the first one. You don't know how to do the first one. Then the rest you wrong already. If the first one wrong, the rest were wrong. Okay, so if no question about this 0.3, you should able to do the 0.5, right? So okay. Initially I plan to ask all of you to calculate, but never mind, I'll just give you the answer. Right? So I assume all of you know how to get all these numbers already. And when it comes to January, okay, can you try to forecast number 13 by using same equation? Since I give you the numbers on the screen here, can you calculate month number 13? I'll give you another maybe 20 seconds. Nevin, are you there? Nevin, I saw your message. Okay, Nevin, yes, calculate month 13 forecast. What is the numbers? Okay, I'll give you the formula here. Nevin, we are waiting for your answer. What is the answer for this one? Yep.
So 51.79.
51.79. Okay. Let's check. 51.7. Okay, good. Nevin, seems that you understand how to do the thing already, which is good. You know how to do alpha, you should know how to do 0.5. You just change the alpha value here. The method still same. All right. So, so the last value here is the final forecast for period 13, which is the next year January forecast. All right. So again, I'll leave you to go for 0.5 as your homework. Right. You can practice this one during your revision. Okay, so you get this data. Okay, so you can see the data over here for alpha 0.3, alpha 0.5. By looking at the data, sometimes it's very challenging for us to imagine the trend. So one of the tools that we use is to plot graph. We plot the graph forecasting numbers with the month on using Excel or using plotting tools, right? You can plot all these numbers. You know that in the exam.net, there is one mathematics plotting tools. You can plot the tools if the question asks you, but normally I won't ask you to plot graph because it's very time consuming, right? So I transfer the data of alpha 0.3 and 0.5, my forecast value using alpha 0.3 and 0.5, and my actual demand data, I put on the graph. My y-axis is my forecast and demand, either is forecast value or demand, y-axis. My x-axis is the month. I put my table here, but basically just to guide you through the concept. The demand and the forecast, y-axis, and the period for January until next year, January. As you can see here, you see the actual data fluctuate like this. And you have two smoothing forecasts, which is 0.3 and 0.5. Can you see the effect after you do smoothing? Whether it's 0.5 or 0.3, you see what happened to the peak? All the peak was suppressed. It's like you're having a filter in the electronic signal. The peak was suppressed. Okay, these two peaks you're not able to see, and both showing the same trend. You still remember we have a behavior, trend, moving up or move down. We have cycle. Okay, we have trend, we have cycle, we have periodic or seasonal pattern, peak, flat, peak, flat. This is trend. We call it trend. And these two peak, you see, let's see. Okay, if you only have two peak like this, it considered as a random activity. Okay, but if you see there's a peak here after every 3 months, let's say March here, you have a peak. June, you have a peak. September, you have peak. Then you are having a seasonal trend. Okay, means month 3, there's a peak, then flat, peak, then flat, then peak. Okay, but basically you can see a trend there. It's moving up. So basically the two methods that you use, or two constant value that you use, basically they are projecting the same trend. It's only smoothing out the raw data. Both are behind the actual demand, means it's go way below the actual, most of the actual point here. You see these two lines are basically below the actual data. So this one is you can see the smoothing effect. It move out the peak or the fluctuation. So here you see if you have alpha, you increase your constant. You increase your constant to 0.5. So it react strongly to the change of demand. So you can see this is 0.5, right? And 0.3. What happened? If you see there's a previous month, there is a peak there, the line will go up a little bit. And then the line go down, right? The line go down. You see there's a 0.5 here, go down a little bit. the gradient of point to this point is a little bit steeper compared to 0.3 lines here. Okay. Yeah, both generating the same upward, means positive trend. We disagree with the trend also. Another word, if you mix with management student or management colleagues, they will use the word lag. Forecast lag the trend or the actual demand. Meaning you see these two lines is below, they are below the actual demand, means you can use the word lag. Okay. They are behind the actual demand. Okay, so this one you can download from my slides later, but this is just a graphical interpretation from the data. You will see this kind of homework in your coming assignment, but I won't expect to ask you to plot graph in final exam. Calculation, yes, but not graph in final exam. Assignment, yes. Okay. And if you want to pick between 0.3 and 0.5, okay, if you want to pick between alpha 0.5 and 0.3, it's recommended you pick 0.5 data for forecasting. Why? Because 0.5 is nearer to the real data. The line is nearer, closer to the real data compared to the red color line. Red color line, yes, it's flatter more, but you see the gap between the points is huge compared to 0.5. 0.5 is nearer to the actual data. Okay, here we stop for a while. Let me stop the recording.